Hello friends, welcome to video lecture on engineering mechanics. So in this lecture, we'll see the introduction of engineering mechanics. Myself, Mr. Prashant Kshirsagar, working as assistant professor in Department of Mechanical Engineering. So I hope all of you are safe and fine in pandemic situation because of COVID-19. Let's start with the journey of engineering. Do you know what is engineering? Yes, here is the definition of engineering. Engineering is the use of scientific principles to design and build machines, structures, and other items, including bridges, tunnels, roads, vehicles, and buildings. Now, see here the basic components of engineerings already are seen in the definition. Now, see main components: science, technology, maths to bring about designing, building, and building of here machines and structures. So here is the world of engineering. Enjoy the simulated models of various sectors in front of you. So what's about this one? This is nothing but PNZ. We are not going in depth of any branch right now. So here computerized numerical control machine in front of you. This is belongs to mechanical engineering. So another diagrams in front of you. These are nothing but the simulated models of automobile field. So this is nothing but the crash test. So dynamic analysis by using the various softwares in front of you. So this is about the simulated models of electronic devices, electrical devices. So what's about this one? A very interesting part. What's about this? This is nothing but the aerospace engineering. What's about this? Yes, this is the Chandrayaan. What's about this one? This is nothing but the rocket launching. So what's about this one? This is the telecommunication or the field of electrical engineering. What's about this? Beauty of architecture and civil engineering. What's about this? This is nothing but the big ships. Yes, purposefully I have taken the pause for few moments. Enjoy this all the diagrams, images, simulations, models in front of you. Now see, what's about this one? I know all of you are belongs to this branches. So the definitions of few branches are in front of you. The first one is nothing but the mechanical engineering. Is an engineering branch that combines engineering, physics, and mathematics principles with the material science to design, analyze, manufacture, and maintain mechanical systems. It is one of the oldest and broadest of the engineering branches. So what's about the automobile engineering? It deals with the design and creation of vehicles used as means of transportation by roads. Essentially, it is derived from mechanical engineering. More especially, it is the branch of engineering that deals with the design, development, manufacturing, production, testing, repairing, control, and management of automobiles. It is a combination of different elements of mechanical engineering, electrical engineering, electronics engineering, software engineering, and safety engineering. So computer engineering. It is defined as the discipline that embodies the science and technology of design, construction, implementation, and the maintenance of software and hardware components of modern computing systems and the computer controlled equipment, electronics and telecommunication engineering. It deals with the electronic devices, circuits, communication equipments like transmitter, receiver, integrated circuits, that is IC. It also deals with the basic electronics, analog and digital transmission and reception of data, voice and video, for example, AM, FM, DTH, microprocessors, satellite communication, microwave engineering, antenna, and wave propagation. Now, enjoy this fundamental principles. Yes, what's about this one? This is nothing but Newton's first law of motion. Do you know what is Newton's first law of motion? Yes, every body continues in a state of rest or uniform motion in a straight line unless it is acted upon by unbalanced force. Now, look towards this one. The body will not move initially, but when we apply certain external force on that body, the body comes into motion. As per Newton's first law of motion, the body will not move as it is without application of external force. So what's about this one? So here we have seen the body comes into motion by application of some force. Now here, as per our definition, every body continues in a state of rest or of uniform motion in a straight line unless it is acted by unbalanced force. So what's about this one? The celestial system, in which every satellite will move around the center, that is sun. This will continue as it is until and unless no external force is act on that body. So what's about this one? Now try to recall that definition once again. Every body will remain in a state of rest or uniform motion unless it is not acted by some external force. Now see why this rider is falling? Because of obstacle comes. Okay, what's about this one? This is about the Newton's second law of motion. Yes, what's about the Newton's second law of motion? The acceleration of a given particle proportional to impressed force and takes place in the direction of the straight line in which the force is impressed. So the mathematical statement in front of you, F equals to ma. This can be defined in another way. The rate of change of momentum of body is directly proportional to the impressed force and takes place in the direction of the force. Now see, this person trying to hit on this one, the bar here, means the force is applied on this circular body and the body moves in upward direction. So what's about the basic equation? F equals to ma. So depends upon this force applied here, you can get the relation for the product of mass and acceleration. I hope the first law and second law is clear to you. Now see the interesting. So what's about this one, this one, this one? Yes, this is the Newton's third law of motion. What is the Newton's third law of motion? for every action there is equal and opposite reaction. For every action there is equal and opposite reaction. Try to observe in every picture what is exactly going on here. So whenever some object is fired from this, okay, whatever the force is required to throw that object in outward direction, the same amount of the force is applied in back direction. Here the same concept, here also the same concept. This person tried to fire with the help of gun. So whatever the force required here to move that bullet in forward direction, the same impact comes on its shoulder. Now what's about this one? So this is nothing but the Newton's third law of motion once again. So whatever the weight of this lady is not sustained by this chair, because of this the lady falls on the floor. We'll pause for few moments, just enjoy these slides. Now move towards a next slide. What's about this one? You remember who is this? Newton. So what's about this story? Apple falls from the tree on the Newton's head. That time he got this relations. So what's about this one? This is nothing but the Newton's law of gravitation. So what's about this Newton's law of gravitation? Do you remember? Yes, the force of attraction between any two bodies in the inverse is directly proportional to the product of their masses and inversely proportional to square of distance between them. So what's about this G? G is nothing but, yes, the universal constant of gravitational attraction. Now enjoy these slides. So in the journey of engineering mechanics, we are going to study this various interesting motions in the second part of engineering mechanics. So what's about this one? Here in the first figure, with the help of this mechanism, one object is thrown with some velocity at some angle. See the distance of this object from this point up to here. Okay, such type of the problems are included in our syllabus. We are not right now going in depth. So with which velocity that thrown in air, what about the here striking velocity, etc. That things we'll discuss during actual syllabus. What's about this one? Very interesting one. When any object thrown in a space, okay, after some time that will start to fall on a ground again. So which velocity components possessed by that particular object, so that the object takes again the downward journey. Okay, means every object possesses the two components, the first one in the horizontal direction, another one in vertical direction. after some time throwing this object in a space, if you observe here, the one component, vertical component, get vanish and the return journey of that object start. Yes, that's why the object falls on the ground. Now see, interesting one. So what's about here in going on? Here the monkey try to capture that object, or we'll just say the fruit fallen from this tree. Now during this one, whatever the path followed by this one is nothing but the curve path, or this path is known as projectile path. About the next one, here the interesting one. Observe this diagram carefully. What's exactly going on here? Yes, this will clear to you from the top view. Here the pilot try to drop one object from this spot and the target point is here. Means with which velocity, at what angle object falls on the ground so that it will hits with the target point. Okay, such type of the problems are included in the second session of your engineering mechanics course. The same thing here, one person trying to throw the object from this point towards the ground. Something information with us in terms of the distance. Okay, nothing but the once again the projectile motion. Interesting one here, something obstacle is given here, the dimensions for this one, obstacles with us, vertical distance with us, horizontal distance with us, here somewhere the target point available with us, at which velocity we can throw that object from this spot so that that will hits with the target. Such type of the problems are included. Now what's about this one? This case is also to do with the projectile motion. At what angle I can throw my object in a space so that the object will covers the maximum range. That will depends upon the angle. Okay, these things will clear to you when we'll see actual subject. What's about this one? Yes, see the combined moment. Let us say a rectilinear motion. Now see here the ball thrown by this boy in a straight line motion or a rectilinear motion. Now see the combination of a rectilinear motion and parabolic motion. Next, rectilinear, parabolic and circular motion. Here the rectilinear motion or straight line motion from this portion up to here, parabolic, and next one circular motion. See what's about this one? Orbital moment. Okay, now in the same way the person trying to hit this target point from its reference point. Okay, such type of the problems you have to think over it in our syllabus. Okay, let's start with the actual journey of this engineering mechanics course. So it is the science which deals with the physical state of rest or motion of bodies under the action of forces. Do you know what is the common in all the fundamental principles we have seen by considering first law of motion, second law of motion, third law of motion, and then next one, Newton's law of gravitation? What is common? Yes, here force is common. Now see the definition. It is the science which deals with the physical state of rest or motion of bodies under the action of forces. Okay, already I discussed the name of this subject, engineering mechanics. Definition just now is seen. Now, this subject is broadly classified into four sub branches, that is statics, dynamics, kinematics, and kinetics. We'll see the definitions of this one in when we start the actual syllabus. Now, for this subject, 3 hours are allotted per week. So what's about the weightage given for this subject in terms of marks? So for the first test and second test, 20 marks is taken. We are going to take the average of this two tests. End semester examination weightage is given 80 marks, and for examination the duration is given here 3 hours. Means we are going to take the average of this first two tests and 80 marks for the final exam. Means total 100 marks weightage is given for the theory assessment. Now see the actual contents in the syllabus. So what's about the objectives? Objectives are nothing but here. What's about the basic principles with us? We have to apply that basic principles, and whatever the results or conclusions we can get it, that are nothing but the outcomes. Objectives with us in terms of basic principles. Now see here, to familiarize the concept of equilibrium and friction, to study and analyze motion of moving particles or bodies. Now at the end of this course, the learner will able to illustrate the basic concepts of force, moment, and apply the same along with the concept of equilibrium in 2 and 3 dimensional systems with the help of free body diagram. Demonstrate the understanding of centroid and its significance and locate the same. Then correlate a real life application to specific type of friction and estimate a required force to overcome friction. Establish relation between velocity and acceleration of a particle and analyze the motion by plotting the relation. Illustrate different types of motions and establish kinematic relations for a rigid body. Analyze particles in motion using force and acceleration, work, energy, and impulse momentum principles. Now see, before start with actual syllabus, we must know the something information related with the subject, that is known as prerequisites topics. So this includes resolution of forces, use of trigonometry functions, parallelogram law of forces, law of triangle, polygon law of forces, Lami's theorem, concept of vector algebra, uniformly accelerated motion along straight line, then motion under gravity, projectile motion, time of flight, horizontal range, maximum height of a projectile, law of conservation of energy, law of conservation of momentum, collision of elastic bodies. Now see what is actual syllabus. So here is the first module. The first model includes the two subpoints. First one, system of coplanar forces, and second point, resultant. So in the first point, we'll see the classification of force systems, then principle of transmissibility, composition and resolution of forces. In the next point, we'll discuss about the resultant of coplanar and non-coplanar force system, forces, parallel forces and non-concurrent, non-parallel system of forces. Movement of a force about a point, couples, Varigna's theorem, force couple system, distributed forces in plane. Then in the second module, we'll cover this part, that is centroid. First moment of area, centroid of composite plane laminas. So this column indicate how many lectures required to complete this particular model. In the third module, we'll learn about these points. So it includes the two subpoints, equilibrium of system of coplanar forces and equilibrium of beams. So under first point, condition of equilibrium for concurrent forces, parallel forces and non-concurrent, non-parallel general forces and couples. Equilibrium of rigid bodies, free body diagrams. So under the next point, we'll cover types of beams, simple and compound beams, types of supports and reaction, determination of reactions and supports for various types of loads on beams, excluding problems on internal hinge. Then in the next module, friction, will cover these topics: revision of static friction, dynamics or kinetic friction, coefficient of friction, angle of friction, laws of friction, concepts of cone of friction, equilibrium of bodies on inclined plane, application to problems involving wedges and ladders. So in the next module, we'll cover these points: kinematics of principle, motion of a particle with variable acceleration, general curvilinear motion, tangential and normal component of acceleration, motion curves, that is AT, VT, ST curves, application of concepts of projectile motion and related numericals. Under kinematics of a rigid body, we'll cover these points: translation, rotation and general plane motion of rigid body, the concept of instantaneous center of rotation for the velocity, location of ICR for two link mechanism, velocity analysis of rigid body using ICR. The last module we'll see kinematics of particle. Under this we'll cover force and acceleration, introduction to basic concepts, D'Alembert's principle, concept of inertia force, equations of dynamic equilibrium, Newton's second law of motion. Here the analysis limited to simple systems only. So this is about the syllabus. Now say how the assessment or how the examination will be conducted on that actual syllabus. Here the two tests are conducted internally. For that 20 marks weightage is given and we are going to take the average of that two tests, and here end semester examination, for that 80 marks weightage is given. So the nature of question paper. Here question paper consists of total 6 questions. Of these 6 questions, question number 1 is compulsory, and that is based upon the entire syllabus. So the weightage given for every question varies from 3 to 5 marks. Just go through the question papers. I'll share that question paper in the next lectures. So question number 1, the weightage is given for the sub questions varies from 4 to 5 marks, and that question number 1 is compulsory. And from question number 2 to question number 6, you have to solve the 3 questions. So each question carries the combination of marks in the range from 4 marks, 8 marks, 6 marks. So total 20 marks weightage given for the question number 2 to question number 6. And you have to solve how many questions? You have to solve total 4 questions. Now these are the reference books in front of you, but we are going to use engineering mechanics by Dayal book. That is actually right now not mentioned here, but remember we have to use engineering mechanics by Dayal book. That also I'll share in the next lecture. Now this is about the laboratory work or the practical work. For this, total 50 mark weightage is given. Okay, so it consists of 2 parts. First one term work part, and next one practical and viva part. So what's about the objectives? So already I've seen the objectives of our engineering mechanics course. In a similar way, the same concept, same basic principles you have to apply for the various systems, so that we can get some conclusions and results. These are nothing but the outcomes. Now see here, total 8 experiments list in front of you. Along with these 2 links are given here. So out of these 8 experiments, we are going to conduct here 6 experiments. And what's about this one? This is about the virtual lab. So what's about the meaning of virtual lab? That will clear to you in the next slides. So what's about this one? Nothing but the list of all the assignment related is given here. So on the every topic we are going to give here 3 to 4 problems, and you have to suppose to be submitted after completion of that assignment. So term work part consists of laboratory experiments and assignments. The distribution of marks for term work is as follows. For practical work and journal, 10 marks weightage is given. For assignment, 10 marks weightage is given, and for the attendance, 5 marks weightage is given. Now if you look towards the entire weightage given for this subject, you can get these details as 80 marks given for the theory, 20 marks is given for the internal test, 25 marks given for the term work, 25 marks given for the practical as well as for the oral. So total 150 marks weightage given for this subject. What's about the end semester examination as far as concerned with the practical work? The pair of internal and external examiner should conduct here the oral examination. Depends upon the entire syllabus. So what's about this one? Here, these are nothing but the actual setups of apparatus on which we are going to conduct our practicals. So what's about this one? This is nothing but the universal force table. With the help of this table, we can complete the first experiment, that is verification of law of polygon of forces. What's about this one? This is nothing but the parallel force apparatus. We are going to get the reaction details with the help of this apparatus. What's about this? This is nothing but the inclined plane apparatus. So here we can get the information regarding coefficient of friction between two surfaces. What's about this one? This is nothing but the bell crank lever apparatus. So with the help of this one, we can prove the moment of forces or law of moment. So what's about this one? This is nothing but the collision of body apparatus. Now, so what's about this one? So the list of that experiment, the two links are mentioned like this one. Now we are going to conduct the virtual experiments. Okay, so what's about this one? The projectile motion, we have seen the different pictures. Now by changing some values here, we can get the different range or patterns of this one with the help of virtual lab. In a similar way, you can get the information regarding the collisions of body with the help of that virtual lab. I hope you get the details of the engineering mechanics subject. Thank you. In the next lecture, we'll discuss about the actual syllabus.